Hi, this is Michael Sweringen, and I'm going to be asking questions and giving answers to the excellent slideshow by Professor Kevin Anderson. So here's the title of his lecture, Climate Change, Going Beyond Dangerous. This is Professor Kevin Anderson of the Tyndall Center. First question. The Rio Earth Summit was in 1992. What have carbon dioxide emissions done since that summit? Gone up, gone down, gone up and gone up faster, or stayed the same? They've gone up and they've gone up faster. Even though scientists are well aware of how dangerous things are getting, emissions are going up. This is very dangerous. We need them to peak and to start coming down. The Copenhagen Accord of 2009 says we've got to keep the global temperature below 2 degrees Celsius and have it be consistent with science and on the basis of equity. Why do you think they added on the basis of equity? What does stopping global warming have to do with issues of equity? I can think of a few things. First, industrialized countries are most responsible for global warming, and America, the most responsible. We should bear the majority of the cost. Low-wage countries such as China and India produce lots of carbon dioxide, but they're manufacturing products for consumers in wealthy countries. We essentially farm out our manufacturing to them. All the industrialized countries have produced lots of carbon dioxide as they developed, and it's not fair to ask developing countries who want to give better lives for their people, but say, now you have to do it without emitting carbon dioxide. Rich countries should cut first and cut the most. The key question is, how do we ensure a good chance of staying below 2 degrees C? What does this number refer to? 2 degrees Celsius. Two degrees Celsius is the difference in temperature between the pre-industrial age, that is before the Industrial Revolution, about 200 years ago, and 2 degrees C is the maximum safe temperature today. So that gap is 2 degrees C. What is the importance of this slide? One is from 2001 and one is from 2009. This is a tool to visualize the impact of global warming on 5 general different areas. And you can see the more red it is, the more dangerous it is. And that's where they came up with the idea that 2 degrees C could be safe, and so we should shoot for that. However, as scientists have learned more and more, they can see now that areas they thought were safe are actually more dangerous. So you can see there's more red lines at 2 degrees C in 2009. With more knowledge, 2 degrees is more dangerous than originally thought. When a political leader says, we will reduce our emissions by 80% by 2050, what does this mean? This is very common, by the way. It means not in my term of office, so who cares? It means nothing. The only real number with meaning is cumulative carbon dioxide emissions. That's the only number because that's what sets the temperature of Earth. Here's how it should look. We're not going to reduce it by some percent at some time. It would be hard numbers. We in the United States produce 6 billion tons of carbon dioxide each year. We'll produce only 5.5 billion by 2014, 5.0 by 2016, 4.5 by 2018, 4.0 by 2020. These are true numbers and hard targets, but that is what we need to solve this problem. Only cumulative carbon dioxide emissions matter. How does this change how fast we need to act? It means we need urgent and radical reductions in carbon dioxide now. Instead of technology will solve this sometime in the future. There's nothing to worry about today. How much did the recent recession reduce our carbon dioxide emissions? You figure people are buying less, traveling less, more people unemployed. That should reduce emissions. Did it? Yep, a little over 1%. But that was basically a blip in a rapidly rising carbon dioxide emissions rate. We're now increasing CO2 emissions 4 to 5% a year. We're actually going in the wrong directions. We need to peak and then start reducing them every year. What do we mean by the greenhouse gas emissions peak, and why do we want to hit it as soon as possible? The peak is the year that we, our planet, reaches our highest greenhouse gas emissions, and then they go down every year from then on. The sooner we hit the peak, the more time we have to cut our CO2 emissions. The longer we wait, the deeper and more painful our carbon dioxide cuts have to be. Greenhouse gas reductions of greater than 1% have only been seen when? The collapse of the Soviet Union, the Civil War, economic recessions, when Jimmy Carter was president. And the answer is, trick question, 2 answers. One is during economic recessions, but the collapse of the Soviet Union, which was massive, had a 5% reduction in CO2 that lasted 10 years. We need to be reducing our CO2 at that level and more. What are some of the flaws in the standard analyses of the global warming problem? They get the growth rate up to peak emissions wrong. They're saying, oh, we're slowly increasing 1 to 2% a year. It's 3 to 4%. Second, they pick the peak year of CO2 emissions too soon. In some models, they have it as 2010. We've already blown by that. 2015, 2017. They assume rapid deployment of wind and solar. We need this technology, but it takes longer for the conversion from fossil fuels, and we need to move faster than this. They assume slow, slight tweaks can fix this, but it has to be dramatic, revolutionary changes. We miss the window of slow, slight tweaks. Okay, let's just say 2 degrees is too darn hard. How about if we settle for 4 degrees? It's only a couple degrees more. What's the big deal? Okay, so let's settle for 4 degrees. What will the planet be like? Well, 70% of the planet is covered with water. So when you get a 4-degree global average, that means it's 5 to 6 degrees C over land. And what we really have to worry about are the hottest days. So if we live in a 4 degrees C world, that means it will be 6 to 8 degrees C warmer in China, 8 to 10 degrees warmer in Europe, and 10 to 12 degrees C warmer in New York. That's 18 degrees Fahrenheit warmer. So normally where we would see a dog day of August, a 95-degree day, now it's 113 degrees. Here's one of the biggest problems. At 4 degrees C warmer, you get 40% less rice and maize production. And we're also heading towards 9 billion people. So we're going to have less food, more people. The scientists who have looked at this say a 4 degrees C world is incompatible with an organized global community. Also, if we hit 4 degrees, there's a good chance we're going to pass some tipping points that'll heat the planet even more. We probably can't stay at 4 degrees. It'll get even hotter. We must do everything possible to stop this. What percent of the income of the average American does the average Chinese person have? How about the average Indian person have? The average Chinese person has 5% of the income of the average American, and the average Indian person 2%. Here's the problem. It's tremendous room for growth. We want to give them better lives. But that usually comes with rising CO2 emissions. He says, we have a magician's view of time and a linear view of problems. What does Professor Anderson mean by this? We kind of think if we don't do this now, we'll just do it later. Hey, now we're working on economic growth. We just need to get jobs. We'll do it later. Unfortunately, this is a cumulative emissions problem, and it doesn't work this way for global warming. The longer we wait, the harder it gets. And the linear view of problems, we think, okay, 2 degrees is bad, 4 degrees is just twice as much, and that it'll be twice as bad as 2 degrees. However, you get unexpected feedbacks as you head past 2 into 4 degrees, and these feedbacks can make it much worse. So even though it's only 2 degrees warmer, you could have many times more problems. In the interest of fairness, we, the wealthy nations, need a 10% reduction of carbon dioxide emissions every year, year on year. That is a lot. This is a bold question, Professor Anderson puts out. Are we, the wealthy countries, sufficiently concerned to make or have enforced substantial personal sacrifices and changes to our lifestyles right now? This is simply what we have to do. This is a mind experiment. If scientists have the numbers right and they get that so many billion tons of CO2 results in this kind of temperature, and if developing countries peak their CO2 usage by 2025 or 30, and if we make rapid reductions in deforestation emissions, and if food emissions are 50% less by 2050, in other words, we can grow food and it uses only half the CO2 emissions that it uses now. And if there are no surprises, no tipping points, and if we reduce carbon dioxide by 3 to 4% per year, then what? Then 2 degrees C is virtually impossible, and 4 degrees C by 2050 to 2070 is likely. This is a dire situation. The current economic system and the current political system make this impossible. That's a quote from Professor Anderson. We need to look seriously at changing both so that we can solve this problem. This is rough to listen to. This is rough to learn about, but it's accurate. And so we need to face it. Thanks for listening. I'll catch you on the next video.